Okay guys, pre-startup check.
I mean, a lot of this stuff we're talking about is on your handout.
Yeah, so I put on here, use the latest edition. If y'all don't know what that means, who doesn't know what that means?
Enlighten us.
Use the latest edition. So Sam puts out an edition for every piece of paper that we use, every checklist that we have. The latest edition is the last one that she's printed out. It could be 2008, could be 2022 for all I know. But whatever that one is, it's the one we use. The last one that she's made is the last one that we start using. All the other ones go in the trash. Or you can chop them up and use them for scrap paper and write on the back of them for notes. If you don't do it already, take notes. Take notes every time you go out to a job site. If that means you take an old sheet of paper that has something on the other side and you take it out there because you don't care about it getting dirty, and you write notes down as you go so you don't forget stuff. Take pictures, take notes, make sure you get all that stuff down, so when you go over your pre-check start list and you're like, well, I already verified all this, I've got it right here, I can look at my notes, I'll have it. And then I fill out this latest sheet and it says, I wish I had one in front of me, but it says, do you have water to pump? It talks about seals, it talks about packing, it talks about flush lines, and it talks about everything that you possibly could think of. Have the valves been operated yet? Have they been exercised? Do we know that they work in sequence? Do we know all the parameters are set? We've already gone through this once. We've already done all this, so we should know. So we use the latest checklist. Once we fill out that latest checklist and we make sure that we're good to go, we still have more work to do. We're going to check the runout of the shaft and the coupling. So we're going to couple it up and we're going to find out, or check in the motor and find out what the TIR is. Shouldn't exceed 5 thousandths on any new installation. If you have an old installation and we're just connecting it and it has more than that runout, you probably ought to make a phone call and say, hey, is this acceptable? What's this going to do? If we put a new seal on it, are we gonna warranty something that doesn't meet our expectations? So we need to make sure that they understand, hey, you may have more problems than what we're looking at. See if they want to do anything about it. So measure shaft and motor couplings and the shafts. Here's where we talk about the total impeller lift. So we've got to measure the lift and we've got to figure out what the lift is. What is total impeller lift?
Set it all the way up.
Total impeller lift is the amount of space. Go ahead, Brad.
And how much you're going to pull the impeller up off of the space.
Off the seating flange, whatever that happens to be. When it's in its total down position, if it has a lateral wear ring, or if it's axial wear ring, or if this is a semi-open impeller, or if it's a prop pump, they all sit down on the bottom. So the shaft will sit on the base, or your impeller will sit down on the wear ring of some sort. You're going to sit down flush. So once that's lifted up off of there, then we start measuring the clearance between the impeller or the wear ring faces. That's our total lift, is the lift between the impeller and the seating surface. Impeller should be calculated after free rotation is achieved. So if you don't know what this means, you should be able to turn the shaft on the pump and the motor before you actually calculate any impeller lift. This is right when it starts to turn freely and we have no more drag, then we're going to start calculating lift. So this way we know that we pulled the stretch out and we can start calculating the amount of total lift that we put on there. The lift, the style, the size, all this will determine the amount of clearance needed. If your impeller is a full open impeller, then your impeller is not touching regardless, but you still have to lift it. And at that point, you still want to stay in the bearing, but you have a sleeve and you have a total amount that you will lift up and a total amount that it will go down. Your actual indication of impeller setting is right in the middle. That's where you're supposed to set it. So your full lift, and then you calculate that full lift and you cut it in half. Okay? Questions? What would the impeller lift be on a closed impeller? Does anybody know standard closed impeller with a 2-inch shaft?
No,
Well, we'll work on that later. Okay. Okay, impeller lift. Remember, there's the S's: style, slope, and stretch.
These aren't my girlfriends from college.
These are Trent's. These are Trent's slides. Style, slope, and stretch. Remember the 3 S's: style. As you see here, we have. Is that an impeller?
That's a close.
Closed.
Kind of hard to tell.
It really is.
Going by the numbers on the bottom, it's closed though.
Yeah, 3/16 to 1/4 inch. As you see here, this one is much easier to tell. It's coned with no plate on the bottom, so the impeller clearance is going to be between the impeller and the sleeve on the sides here. So 15 to 30 thousandths, and remember this is after free rotation. No, I'm wrong.
I don't know what you're pointing to.
No, is this not the impeller?
Go further out.
Yes, that's
That's
the
open
cut
impeller.
with the.
Oh, here.
Right.
Yeah.
All right, here we go. Right here. It's a great drawing.
So this is the drawing you get if you're looking at flow surge sheets. This is.
Oh, this is it.
What I would share is the model name tells you everything you need to know. You'll see E&L means enclosed. S&L means semi-open. So you can tell.
This is on flow surge.
This is on flow surge. So you can tell from their model numbers, and most of what you're going to be installing startups are flow surge. You can tell what that impeller type is based on their model.
We work on all different types of pumps. FlowServe is the one that we rep. So when you go to another brand, say you're doing a Fairbanks, if you're still in those numbers, the letters, and E and N, that still means the same thing. But if you have any questions on that and it's not on the nameplate, a lot of times your lift will be on your nameplate. And if it's not on your nameplate, then you need to call somebody. Call me, I'll direct you to the right person, or I'll find out for you. If it's not in your Traveler, it should be in your Traveler and it should be on your nameplate. But on the rare occasions that somebody missed it, let's make a phone call and we'll find out what it is. We can always go by the model number. Okay? Impeller lift.
This is the second S.
This is key. This is your shafting. So if you look at this, anybody know what the shafting is? Split ring and key. Okay. So this we have two. You have two seashells, and they will fit into a groove with a key on either side of them, and these lock into place. And then you have a coupling that will slide over them, and they're either held with a snap ring or a spiral lock ring. On occasion, you'll see these with set screws. Stretch. This is a calculation for stretch over 40 foot, base to bell. Stretch over.
It's funny watching you try and figure out my slides.
I know.
Okay, so
keep in mind, when you start this up, things are gonna change with time. That pump is gonna turn on and pressure is gonna act down. It's gonna press down on our impeller, and that's gonna increase the thrust on the shaft. We're talking metal, you think metal is not bendable, guess what? We're talking about forces that are gonna move that metal. And the graphic there shows you that there's more area on the top of the impeller than on the bottom of the impeller for that pressure to act on. So hydraulically, these pumps all have different characteristics based on their impeller geometries, but that basically what you need to know is there's going to be additional force on that impeller that stretches the shaft, and it stretches based on a formula. Our rule of thumb is if your pump's less than 40 feet, it's probably negligible, especially if you're an open or an enclosed impeller, because you've got that margin of clearance from the seat. If you're semi-open and you're trying to measure 15 thousandths, you can stretch 15 thousandths real easy, and then you're going to be dragging the impeller, and that's when it all goes to hell. So if you're over 40 feet, let's talk about what our stretch is going to be. There's a formula. P is the load, the down thrust, L is the length, A is the area, cross-sectional area of the shaft, E is a factor called Young's modulus, 29 times 10 to the 6th for stainless steel. So we just plug all that into a spreadsheet, and it tells us, so you're going to stretch. Oh, we really want to know what it is at shutoff, because when you first turn on, you're going to get that full load down on the shaft, and that's when you'll drag. So we'll do that calculation for you and give you. Really, you don't need to be asking, hey, what's my stretch? You need to say, hey, what's my total lift? And let's factor in that coupling slop, how much slop we got in our couplings, how much stretch we're going to have on our shaft, and what the initial setting will be. Where we run into problems is when our customers will do this. That name tag said 30 thousandths. I put it at 30 thousandths. Yeah, you screwed it up.
There's rare occasions when you're actually going to see that, like if you have a short set pump with no head, and it has a semi-open impeller and it says 10 thousandths, you could probably get away with setting it at 15 thousandths. But if I read this correctly, Trent, the FlowServe says on semi-open impellers, the at shutoff is the only time that it ought to be close to drag. They said if it's set correctly, at shutoff head, it will drag slightly. I wouldn't want to get it that close, personally. But I don't know.
Question for you. Do you have any slop in a threaded coupling?
Definitely.
How much?
Well, I'm going to say 25% because only threads are 75%. What is the...
I don't know. I mean, what if those threads aren't butted up? When that first turns on, it's going to tighten probably with more force than you can put on it by hand.
Well, that's a good way to snap a shaft too.
Yeah.
So we shouldn't be doing that. If you haven't locked your shafts in place on a threaded coupling, then you really need to. And remember that typical thread pitch is only 75% engagement. But our shafts should be stuck together. You still have some stretch. Every shaft has stretch. What that calculation is, these guys know way more than I do. I typically set a little bit low. Yeah. There we go. He put some stuff in here just to trick me.
I was thinking about what you were going to say.
I actually read these slides and I don't understand all the calculations, but guys, I'm not an engineer, and Trent is. So some of these guys that have the engineering degrees, that's why we go to them. I never said I knew all the answers, and I don't claim to, but I do know people that know the answers, and that's where it comes in handy, is that we have a company full of very smart people, and we have the ability to find the answers for you. So if you don't have the answers, just like I don't, we can still call these people and find out. I can say, hey Trent, I ran into this. He goes, well, hey, I'm going to call Wingo. Or I've done that many times. H has told me, get with Wingo, make sure he knows this calculation. He'll set it up for you. He'll run the program for you. So, don't get me wrong, there's multiple people. I just threw Wingo out there as an example. Okay? If we just waited just a couple of seconds, we could have had all the calculations right here.
The table.
Just understand, on a threaded coupling, it's only as tight as the person that put the pump together. So figure out what your lift is, figure out where you get rid of your drag, figure out, add that to your lift, couple it, run it. Then you're gonna uncouple it again after you run it and reset your lift. Because initially, you're gonna fire it up and those shafts are gonna tighten. And that would get rid of your slop. Then, stop it, or let it run for 30 minutes or so, then recheck your lift. On a ring and key, it's gonna stay the same no matter, because you're gonna get that stretch. So, you've gotta figure out what your clearance with stretch is, add it to it, couple it up, run it, listen to it.
Guys, on the threaded coupling, definitely, that's something that I don't think that we always do, is on a closed impeller, it doesn't seem quite as critical. You're already setting 250 thousandths lift, it's a 1/4 inch. Your stretch isn't gonna be enough to make too much difference. You could set it at 3/8 of an inch and it wouldn't make much difference there. But do make sure, does anybody know when we're talking about putting these shafts together? I know that we've skipped over this, but we're talking about coupling here, so it's a good place to put it. When we're talking about a threaded coupling, does anybody have an idea, if you go in and you see one and it's got 6 threads on one side and no threads on the other side, is it acceptable? Is it together? Do we know if the shafts are touching?
You don't know if they're touching, no, but that's not.
We really don't know, because these couplings, if you measure your shaft thread and you measure the coupling, you should have enough to have maybe 2 or 3 threads sticking on either end. Most of your threaded couplings have a hole in them. That hole is to do 2 things. One, it's a centering pin. It's there to measure center. So you run it down. If you had a wire to put in there, you could run it down till the shaft touches the wire, and then you thread the other one in while you hold this one steady. Then if you have 2 threads on this side and you have 2 threads on this side, and you took your pipe wrenches and you locked them together, you're touching. You know that you're in the center. Also, shouldn't be anything between the shafts. Shouldn't have any anti-seize, shouldn't have any dirt, you shouldn't have any trash. And that hole is there just in case some kind of liquid or any kind of adhesive got onto those parts, it'll squirt out of that shaft as well. So it gives you that open area so the shafts can butt up together. Okay? So no anti-seize on the ends of your shaft. They should butt up together without anything and be dry fit. They are machined. Okay, couple your pump to your motor. You see someone doing it right there. After determining your lift, couple your pump and your motor, making sure your couplings are clean and free from damage. Let's do the same thing that we did on our head. Take your flat file and just run it over the edges. Make sure that you have nothing that grabs. Make sure there's no damage done to the coupling in shipment or when it got installed. Make sure nobody hit it with a hammer. I don't know how many times a coupling doesn't want to let go, and when you go to tap it loose, somebody takes a hammer and they ping it, and all of a sudden you have damage. Or you go to put a scraper in there just to get it started, and it mars it up and it leaves a burr. So when you couple it back up, you're going to have a run out because now you've misaligned your couplings. Couplings should be raised in an even motion until mating surface are firmly seated and torque the bolts. When you put these together and you're measuring your lift between your gapping, you should use a bolt on either side of your coupling. and you should lift it until you have free rotation and be able to measure, as according to FlowServe, you should be able to measure that gap evenly, and then you can do a calculation to find out how much gap you have there based on how much lift you're supposed to have. So what was your initial gapping before you had free rotation, and now what is your gapping? Make adjustments to get the correct gapping at that point. If possible, keyways should be 180 degrees apart. I do this for vibration. If we do 180 degrees apart, if we have keyways that are not cut perfectly, then our balance is a little more on the even side. Match marks on couplings will not always line up. Do not try to line them up. There's no reason to. We're doing an adjustment here. The couplings should be balanced, and we shouldn't have to worry about that. Match marks are there because they say this is how we assembled it, this is how we balanced it. But there shouldn't have to be set up together. They're only there initially. Now, if you want to match mark your couplings afterwards to know where they are, that's fine. Verify ease of rotation. How much effort should it take to rotate a pump and motor?
Not much.
Yeah.
Guys, I agree with you. Most pumps should spin easily, but it may be more difficult with larger motors and existing pumps with rubber bearings. When we put in rubber bearings and they add chlorine actually swells rubber, so it will tend to grab a little bit harder, and it'll be a little harder to rotate. So keep that in mind when we talk about free rotation and ease of rotation on startups. It doesn't mean that we can definitely just turn it by hand. We may have to have assistance, and that's okay. And if you do have that and you have questions, then we all know what to do, right? We just pick up our phone and make a phone call. So, does this coupling look right?
No.
Should we have to spin something like that with a pipe wrench? I wouldn't think so, right? If this thing starts up, we're going to do some serious damage. And that's a big pump. That's going to be really hard to turn. You know, that one's not going to turn easily by hand. If you have a basket strainer that's 5 foot tall, that pump's going to be pretty heavy, and it's going to take a little bit just to rotate it. Measure shaft and coupling runout. We should measure shaft and coupling runout. Does anybody know when we should measure shaft and coupling runout?
Before you start.
Go ahead, Joseph.
Before and after the discharge is hooked up.
Before and after the discharge is hooked up. So if you look on your startup sheet, it says before and after discharge. It actually says it right there on it. So we should measure that before and after we do our connection to make sure this gives us an indication of if we have any pipe stream. So if we coupled it up and we said, okay, we have 3 thousandths run out before we connected our discharge, and then we connect our discharge and we have 7 thousandths run out, man, that's a no-brainer. We got pipe stream. You know, let's do something about it. Let's fix it. So pretty much tells you right there all of the places that we're going to measure. I don't know about you, but I've measured the shaft on the motor and the coupling, and they've been under 5, and then the coupling's been over 10. If that happens, then just record your readings. The real key here is that we want the shafts to be in line. The couplings don't necessarily get machined exactly perfect, so that outside surface may not be a perfect machine surface. It may have a coating on there that is uneven by a couple of thousandths, and you're going to see it. You're going to be able to read it, especially if we already have a little bit of run out. So we had 5 thousandths run out on our shaft, and they coated it on one side a little heavy. And we can see that, and it could cause you to think, hey, we got a problem, but you don't. Set seal and install flush lines. I know that we had this before. Now, the deal before is that we want to make sure we have our seals on before we put our couplings. If there's cartridge seals, if they're not cartridge seals, you can't put them on there, and you definitely can't set them until you set your lift. So setting your lift, then setting your seal, that is the only way you're able to make sure that you don't have any clearance between your faces of your seal. If you're dealing with a split seal, make sure you keep your faces clean. I suggest alcohol wipes. They keep them clean because you're going to have to touch the faces. And at some point, once you do touch the faces, you're going to have to get those oils off there. If you do have any kind of contaminants on that face, it will leak. Cartridge seals don't claim not to have a small drip, but they will not have a steady stream. If you have a steady stream, you've done a couple of things that could be incorrect. Over tightening them, your seats may not be set up evenly. You could have trash on your faces, or as simple as a fingerprint. So let's be really careful with that. So torquing bolts. This is something that we just went over. When we're talking about torquing bolts on a seal, this is something that has been a major topic for some time now. And if we over tighten or we don't tighten enough, then possibly we're going to either warp the faces or the housing, which we already know if we warp the head, it moves our shaft. So what's the difference between if we over compress our seal housing? It's going to warp our housing, which is going to cause our faces to not line up perfectly. So it's going to do the same thing. So let's not over tighten anything. Let's use the torque specs that are set aside for us. If you don't know what they are, definitely let's look into our Traveler if they're not there. If we're seeing that we're having to make the same phone call over and over again, then let's make a comment and let's make sure we get this stuff put in the Travelers and say, hey, I never get a torque spec. I never know what I'm supposed to torque this seal at. If you don't have that, then we can ask Mario.
We don't see that on the Traveler.
Google it.
Google it. We're not gonna Google it. We're gonna call. We're gonna get that from our.
We found a sheet that we could probably print out and give everybody a copy. I found one on the torque specs from different size bolts. Material wise, stainless steel, regular.
On the seal, so that little paper tells you what.
That too.
Yeah, the instructions
The
will tell you.
instruction tells you what you lose.
So you should have that, guys.
Yeah, that comes with every
That comes
seal
with the
kit.
seal.
Okay.
Yeah.
Preload discharge piping. We're not going to be able to know what the preload is unless we already have that set and we already know what that's been in the past. If we're installing a pump that we've known in the past has exactly a certain amount of preload, we're not going to be able to measure that until we start it up. So starting up a pump, if we set up an indication somewhat what you see here, behind and to the side of your flange or your discharge piping, then you can actually see the movement when this thing starts up. And when we do this, we can go ahead and make corrections. We can start it up, see it run, and then at that time shut it off, and then preload our piping to match what we've talked about. And then leave your dial indicator set up, because this way we can actually verify what we've seen, what we set, and we can see it happen. And then when it shuts off, we can verify that and move back to 0 or to our predetermined set point. Okay. Make sure you have good bases. Make sure you have something that is stable and set in in a singular position without being attached to the pumping itself. So if it's sitting on the floor, it's bolted down, that's great. If you have something heavy enough that you can sit on that it does not attach to it, which if you don't have one, we can come up with one. We have something in Waco called the Christmas tree that we've used several times. We've got here, what you see is I-beams, and in Fort Worth we've used a pipe stand with a piece of angle iron welded to it. So we can get two different positions and we can measure very clearly and see exactly what we're looking at. This happens to be a below grade discharge, but we do this on above grade as well. And it all depends on the size of your thrust rods. Anybody ever adjusted one? Y'all know what I'm talking about? You had to do this? I know Joseph's done it. If you haven't seen it.
We did it in Abilene. People that was.
We did it there.
Yeah.
We did it here.
Yeah, we did it there.
Yeah, we sure did do it right here. Okay.
Yeah, we did.
Okay, we're back to verify ease of rotation. Pump should rotate without drag. We've set our lift at this point. Okay. Again, we'll need to assist some of these because they're bigger than others. What should we do? Anybody? If we have pumps that need assistance to rotate, what should we do?
Pick up the phone. Visual.
I agree with you. Pick up the phone. If you have something, I actually put that in there because I want you to know if you have something that rotates and it rotates harder than you think it should, or it feels like it's grinding. Let's make a note. Let's make some inquiries. Let's find out. Is this normal? Is this something we've seen in the past? Is it actually dragging on a bearing?
Cheater pipe.
Put a cheater pipe on it.
Greenwood.
Discuss operation with customer. H has been touching on this all day. Talk to your customer. Know what they have. Know if they have something available. Know if they don't. Know if they got something going on to the plant. I know for a fact that we've all been stopped by a customer say, hey, we just don't have any more room in our tower. We didn't make enough room. Okay? Or, they say, hey, we had a line bust. We can't pump. Let's make sure before we just go telling somebody to push the button. Make sure they fill the reservoir. How many times have you gone on and it's like, well, we wanted to get everything ready, but we don't want to actually put any water until you are ready. And then we'll make sure that they're not going to run out of water. Have you ever been on a site? We're actually about to go on one. And they have an oversized pump, and the well looks like it's capable of holding about 10,000 gallons. That pump's going to pump more than 10,000 gallons a minute. What are you going to do? How are you going to supply that water? How are they going to do that for you? Let's ask some questions. Let's figure that out. Are they going to recirculate it for testing? I don't know what they're going to do. But we got to figure that out before we run this. Otherwise, you're going to run it. It's going to shut right off. I don't know what's going to happen at that point. Is that, what if we just ran it and they're like, I don't know, something's wrong. It's making a funny noise now. We just burn it up because we're not sucking any water. Let's not do that. Let's open the valves. Typically, we don't own the valves, so we don't open them, but we have somebody do it for us. This happens to be South Lake. South Lake, they typically just ask us to go ahead and do it, and we're there. It's right next to the pump. But let's make sure the valves are open, that we have plenty of water to pump. Starving a pump causes cavitation, it causes overheating, and it will fail your pump quicker than anything. No water, dry runs will burn them up. Purge air. Everybody purges air? What if you got a pump that doesn't have an air release? Are you still doing that? Are we doing that at the stuffing box? Are we doing that at the discharge piping? Are we letting the valve open? Are we listening for it? Making sure we have water? If we're not, it's fairly simple. I mean, pull the hose off of your seal. Let the water flush out. Pull it off of your packing release. It's at the bottom. It should just squirt right out. If we have a valve where we're putting our gauges, let's go ahead and do that. Same thing with the discharge valve. Let's make sure that we have plenty of water to pump and some place to put it. That's recirculation. If we don't, it's just going to run the water that's in the pump, and it's going to run it and run it and run it and heat up. It's going to cavitate. It's going to recirculate, and it's going to burn the outside of the veins. It's going to cause some serious problems. Open your valves. Take your tags off. You remove your lock, and now it's time to energize the equipment. So remember, what's first?
You should know what's around it.
Safety. Safety's always first, right? So make sure you wear your proper PPE, or get somebody that has the right proper PPE to turn the power on for you. And then we're ready to go. Let's check over all of our parameters again. Make sure that everything is still in place. Make sure that we have the right settings so we can get ready to run. All right, Trent. It's you.
All right. We breaking and going outside, or we?
Do you want to do that? Is that what it? Yeah. Hands on. Then you want to come back in and finish this up?
Yep. All right. So hang on. Let me give you some instruction here.